right. I think we're finally ready to go. Got a little bit of a late start tonight, but that is the way it goes sometimes. How are you guys doing tonight? Hope everybody's well. Can you guys hear me okay? If you can, just let me know in the chat real quick if you can hear me talking, whether or not. I know last time there was an issue with that, and this time I have reason to suspect there will be as well. So can you, my OBS says, okay, perfect, cool, thanks. Okay, so the reason it took me a little bit longer tonight is because I'm on a fresh, brand new setup here. And I had a couple of technical difficulties with that. So I actually am on a fresh install of Arch Linux this time. And I've got a new desktop environment installed called Hyperland. And that's what I've been using for the past, I don't know, a week or so. And it's been pretty good so far. There's been some growing pains with it, but I've been experimenting with a new setup because I wasn't really happy with what I had before. So, hey, TME. So basically, I'm going to give a trial run tonight to see how this goes. I do still have my old setup, so if something goes horribly wrong, I can switch over to that. But hopefully this new setup should work. So with that said, I'm going to open a terminal here and go to my development Kohi. And then instead of launching code, I'm going to launch nvim. And this is the other part of my new setup that I've been working on, is I've been working on switching over to Vim because I just prefer it as an editor. And I finally, I think, have things working the way that I want. So last time I think we were working on, what was it, terrain? I think we had, oh, you know what? I might be on the wrong branch, actually. I think we did a feature branch for that. So let me open up a terminal and see what branch we're on. We're on main. I think I did feature terrain. Yes, that's fine. Git reset. /hard. Okay, let's try that again. There we go. Okay, so now I should have terrain. There we go. All right. So last time we kind of left off discussing terrain and kind of how we were going to attempt to deal with terrains. And we started sort of with the implementation of it. And we kind of ran into some things where I'm like, well, I need to make some decisions on some stuff. And the more I got thinking about it, the more I'm like, you know what, we should probably just get geometry rendering first with just a super simple shader that maybe doesn't even use textures at all. And then we can sort of tackle the shader aspect of that secondary. And that'll keep us from having to worry about materials and all that other stuff. So I think the way I'm going to roll this is is a completely brand new feature, basically. And I'm not even going to touch materials or anything just yet. I know we have a lot of that stuff here in code, but I think I'm going to kind of work around that for right now. So the first thing that I'm going to focus on is probably just filling out all of these methods here. So I think in the initialize, if I remember correctly, we had terrain C. Let's see, we had already figured out what our vertices were going to look like. So I think all we had to do was actually load up the geometry. So we have our renderer create geometry where we're sending that off to the renderer to be uploaded. And here is where we actually are handling the material. So yeah, now I kind of remember this is kind of what led us down the material rabbit hole. So I think I'm going to skip this for now and actually set up our shader config to also not take this into account. And we're going to set up a temporary, I guess like a render terrain geometry, which is going to wind up looking very, very much like the structure we have with the calls that we have. But instead of rendering using the material manager, we're going to apply those things in the shader directly. So over here, I'm going to, let's go ahead and launch the shader config for, did we set one up for materials yet? For the terrain? I don't recall where we were at with that. Let's see. I don't think we actually did. I thought we kind of started this, but I guess we didn't. Okay. So under our shaders, we just expand this a little bit. Yeah, we do have a terrain shader. I thought so. Oh, we didn't do the shader config for it. That's why. Okay. So actually, let's take a look at that first. So we have directional light stuff here, point light stuff here. I guess we could leave lighting in. I'm going to comment out anything having to do with materials for now. Because we're going to have to approach those differently. So we will get rid of diffuse color and shininess. Directional light P lights will leave. I'm going to get rid of all this sampler stuff. Including those. The mode. I suppose we could have a drawing mode for this. We probably should, because we're going to need that for debugging purposes. So I'll keep that. All right, so we have our data transfer object includes ambience. I guess we'll keep ambient light, texture coordinates, normals, view position, frag position. I mean, we're going to need all this stuff. I might as well keep all that. The TBN matrix, calculating point lights. The only thing is we're going to have to modify those slightly to not look at texture maps. So like here, we're going to have to modify that a little bit. I think yeah. So we have the sampler here. And then we're only taking the alpha off of that. So let's go ahead and just say 1.0 for that. And we will comment out the diffuse sampler. And then comment out that guy. And actually, we'll wind up doing the same for these guys. I know this seems like a lot of work that I'm doing now, and it kind of is. It might be easier to actually start from scratch now that I think about it, but we will slowly re-enable this stuff as we actually get it put in place. So, oh yeah, this needed to be 1.0. This needs to be 1.0. So here's the diffuse sampler. You know what? Instead of doing that, let's just hard code diffuse sampler, right? That's actually going to involve way less code changes. So that's just a vector 4. So we'll comment out this for now, and we'll say vec 4 1.0. We'll just treat it as an all white texture, right? That way we don't have to rewrite any of this stuff. All right. So this right here is taking into account the specular. And I'm thinking the specular, instead of using the sampler, how should we... I guess for now, I'll go ahead and just say, I don't know, like a 1.0, I guess. I'm not 100% sure how that's going to look. All of this is probably going to look really wrong, but that's okay. We're just trying to render geometry for now. So the next texture here is, see, this is another thing that we probably shouldn't be doing. Look how many times we're actually sampling these things. Like when we rewrite this, and we should probably go into the material shader and fix this too. We're sampling the diffuse and the specular texture a lot. We're doing it once per point light, which is pretty dumb, actually. So let's say vec4 1.0, comment that out, and then we'll just say, oh, this one up here has to be a vector 4 too. And then I'll just do the same thing here. So vec4 1.0. Okay. So I think that is it in terms of, oh, nope, we missed one. Here's the normal up here. So instead of doing this, I'm going to comment this out, and then say normal equals normalize. But that's taking the local normal. Actually, we don't even need to do this. Okay. So I think that is all of the texture sampling. So we've removed that. The other thing that we had was diffuse color and shininess. Diffuse color. Maybe we should keep diffuse color. Although I'm really struggling to understand why we'd need that on a terrain. I suppose we could color the different materials that way per vertex. Yeah, I'll leave it in there. All right. Let's bring this back. You know what? I'll bring back shininess too. We'll tackle that at another point. I don't really want to rewrite that much of the shader. For now, I'm just going to comment out the samplers and we'll deal with the rest later. All right, so that's the shader. I don't think we need to do anything to the vertex shader. Terrain. Oops, that's the fragment again. Of the vertex shader. So I think we're going to keep the same vertex layout. Did we... I know we have terrain vertex. And we're saying here we need material weights. But if we're not doing material stuff just yet, I'm going to comment that out with a to-do. materials. That'll keep me from having to modify this right away. Although I think that's probably going to break the terrain code. Yeah, right here. Okay, so to do materials. All right. Let me do a quick build because I don't remember where we actually wound up on that. So here's our terminal. I will do a build all. Variable frame count set but not used. Oh, right. That was another thing I actually needed to bring up. So on this machine, I'm using Clang version 15, which seems to be a little bit more picky about a couple of things in terms of some of the rules that we've set. For some reason, it wasn't picking it up before on older versions of Clang, but this newer version of Clang is. So there was a couple of changes that I need to make in the code. So this was in engine C. And it was somewhere down here. What was it called? Frame count. Yeah, it's complaining about this variable here, frame count, because we're basically initializing it here and then incrementing it here, but then never doing anything with it, because this is something that I actually need to rework out in terms of locking the frame rate. So I'm just going to comment this out and to do frame rate lock, if I can spell. And then the next instance of that, I'm just going to do frame rate lock. All right. So let's build that again. Use of undeclared identifier frame count. Did I not write this change? Must not have. There we go. Okay. So we're up and running. Hey, Tammin, how's it going? Good to see you. What is being worked on tonight? So I'm trying to make a little bit of progress on our terrains. So what I'm basically aiming for tonight is to see if I can just get some geometry to be drawn. I've decided to turn off materials for right now and just focus on sort of getting some geometry on the screen. And then I'll tackle the materials as sort of like a secondary part of that because that's going to be a little bit more complicated. So I figure this way we at least have a phased approach to it, right? So that's the idea anyway. In addition to that, I'm still kind of getting used to driving my new setup here. So I've switched over to Vim instead of VS Code, just because I've been using Vim every day at work, and I'm a lot faster with it. And so I've tried to translate a similar setup to what I use for work to this stuff here. And I'm finding bumps here and there, but I would imagine probably a couple weeks from now it'll be completely seamless. So that is where we are at. Also, while I have all this stuff up, let me go ahead and see about running real quick. So I do have a debugger installed here as well. So in case you haven't noticed or haven't seen it, by the way, this is a tiling window manager that I'm using. And so you'll notice that it just automatically sort of tiles my view here for me, which is super, super useful, highly productive. So this ought to make my dev workflow a lot easier. What do I do for work? So for work, I basically work on a application that is, think of it as like a 3D room layout type software. So you can place like furniture and cabinets and stuff in there. And it's all based on like OpenGL basically. And so I work on that. Very fancy setup today. Yeah. Yeah, it is. It is kind of fancy, I guess. I'm using a new window manager, so it's like very bleeding edge, but I'm really liking it a lot so far. So, but yeah. Anyway, so we can see here that everything still works as normal, and we can also see that Kohi is cool with weird aspect ratios, which is cool. The Sims Online, yeah. Yeah. The setup I have here allows me to step through my code just like I would in VS Code or anything else. So, I can come in here and set a breakpoint and take a look at the individual local variables that I have set and take a look at the values for all those things and set up watches and all that stuff. So, it's got all that stuff in it. I'm really liking this setup quite a lot. So, but yeah. Anyway, I'm going to go ahead and continue here. Let me get rid of my breakpoint. And I will close the application. Cool. All right. So, that takes care of the things that Clang was choosing to complain about now instead of when I actually wrote it, which was a really long time ago. Anyway, okay, so that is that. Let me switch to terrain C, and I guess the next thing we're going to need is, we don't really need the update, but we are going to need the render. So I guess that's the next thing we can take a look at. So over here, I'll pull up the Vulkan backend, and we will go to, let's see, render, draw geometry. That's the one I want. So this is the standard function that we use to draw geometry right now. And I'm just going to take a copy of this. And let's see, let's go down here. Plop it right here. And we're going to rename it to draw terrain geometry. Right now, we're using the exact same type of geometry, which is just geometry render data and render plugin, but I suspect that these data types may have to change. So we'll see where we wind up with that. Let's see. So we take our Vulkan context. Let me actually scroll this up a little bit so I'm not covering it. So we take our Vulkan context. We check to make sure that we have geometry that's not an internal. The internal ID is not invalid, rather. Here's our buffer data. Vulkan buffer draw. Okay, so I don't suspect that there's much here that's going to have to be done, thankfully. At least not yet. I suspect when we go to modify how this works, we may wind up actually having like a different structure for the geometry that maybe requires us to go to a different place. But for right now, I'm just going to separate this off as is. So I'm going to say select this, go to the H file, and draw geometry. Right after that, we will plop this in here. And save that. In fact, I'm going to save all the buffers I have open. I'm going to need to add this now to the front end. So I will say grab all of this, go to the front end. I'll do the H file first. Draw geometry. Plop this right here. And we will see, I guess we can call this yeah, I guess renderer. Whoops. Renderer draw terrain geometry. Need to export that. That should be good for right now. I'm not going to comment it yet because I'm not 100% sure that we're going to maintain this signature or any of it, really. Let's see. Let me catch up on chat here for a second. Such a coincidence, to be honest. I had plans to make my engine Android compatible so my wife can use it for work. She's an architect, so real-time 3D modeling would be really useful to her work. Heck yeah, that's awesome. That would be a really interesting project to work on, actually. I've always kind of wanted to write a like a 3D modeling program where you actually can get in there and edit the geometry in real time. So maybe that's something we'll do in Kohi. We'll see. Moon pie dumplings. Yes, it's Linux. Yeah, this is Arch Linux, and it's using the Hyperland window manager. Desktop environment, rather. Okay. So, I searched for the Linux tag on Twitch, but you didn't have it. Oh, yeah, you know what? I probably haven't done my tags. That's actually a really good point. I always forget to set that up. So thank you for pointing that out. I'm probably going to set it as like my default. Because I have some defaults in there, but I need to update those. So I probably won't do that this stream, but I'll make sure it's updated for the next one. Okay. So I want to take this and we'll copy this over to the C file. So this is front end C. Let's see, draw geometry. Here we go. We'll put that right here. And then in this case, I think, oh, you know what? We haven't exposed this to the plugin yet, so I'm not going to have anything to call from here. So let's go to the plugin. And we'll add our function pointer. So I'll just put that here. And then draw terrain geometry. Okay. So we'll put that there. And we'll go back to, we want front end C. And we will grab this state here. So we will, oops, other way. Yeah, I think I need that, yeah. All right, put that there. And then state pointer, plugin, draw terrain geometry, if I can type. We need the address of state pointer plugin. And then we need to pass through data. And that should go ahead and hook that up. So at this point, what were we modeling this after? I think we were modeling this after mesh. So let's go ahead and pull up mesh. And I think we called this draw under here. Was it not? Wasn't draw. I thought it was. Oh, you know what? It's the view that draws these things, isn't it? So we draw all these. Apply the global material. Apply the instance. Render draw geometry. There it is. Okay. So this is basically going to serve as our template to draw the geometry here. Now, since we're only dealing with one geometry, like we don't have to do this loop or any of this stuff, all we should really have to do is make this call and then basically the underlying shader calls that are made right now by the material system. So let's go down here, and I guess we'll do our sanity checks first, right? So, oops. So if not T, K error, terrain. Oh, did I do this in the update? I wanted to do the render. All right, so terrain render requires a valid pointer to terrain. I don't think we need the frame data for this, so I'm not going to check for that because we're ignoring it. Oh, this should return false. Okay. So really what we should do is renderer draw terrain geometry, and then I guess we're just going to pass geometry. So T, oops. They just call it geo. Yeah, T geo. Was that a? It's not a pointer. Okay. Couldn't remember if I had it owning that or not. So we need the address of that. All right. So that's going to handle the draw. How many spaces do I have here? Why has this only got 3? Weird tabbing. Okay. All right. So now the next thing we need to do is basically deconstruct what the material system is doing for us, namely at some of these other levels, right? So shader ID. We could probably cache that, but for right now, I'm not going to. So shader system get, and we called this what was it? Built-in dot terrain shader, I think. Yeah, built-in dot terrain shader. Okay. We still haven't configured or created a configuration for that, so we need to do that too. But for now, I'm just going to fill this in. So shader system get built-in terrain shader. That does return a pointer to a shader. Okay. So shader pointer s equals that. And then shader system use by ID, because we're eventually going to cache that, but for right now I'm just going to say SID. So we need to use the terrain shader, and then we need to apply the globals, and then apply instance, and then apply locals, which is going to be basically just the model matrix, right? So those are basically the steps that are going to get us to where we need to be. We also, before we do this even, we also need to have a render pass, which we haven't configured yet. So begin render pass, and after the render, we need to end render pass. Actually, no, what am I thinking? We don't need that. Because this is going to be part of the world render pass, so we don't need that. More than likely, what we'll probably wind up doing is when we render using this view, we'll probably render here before we actually do, let's see. Before we do this, so like right after we begin the render pass, right here. Render terrain, right? And then we'll switch over to using the shader ID that's passed through here. This does make me wonder, though. This does make me wonder if we should be passing through a shader ID like this, because now it seems kind of wrong. Any plans on switching to dynamic and bindless rendering? Potentially at some point. I don't know. Probably not in the near future while we're still implementing basic features like terrain and stuff like that. My thought behind that is we're only doing that in a few places because of some of the abstractions I put in place. So when we go to actually change it out, it shouldn't be too big of a deal. But yeah, I don't want to necessarily. Dynamic would ease the transition to Direct 3D 12 later on. That's probably true. Yeah, I have not looked into Direct 3D 12 all that much yet. When we go to, it's dynamic by default. I didn't realize that. Okay. So yeah, when we go to actually implement DirectX 12, that's going to be interesting because that's going to be a learning experience for me along the way. I've done DirectX 10, 11. I even did some 9 back in the day, but I've not messed with 12 yet. So that's going to be interesting for sure. All right. 12 is fun. Yeah, it should be a lot of fun. I'm looking forward to implementing that actually. And honestly, it'll be interesting to see how much less code the OpenGL implementation is when I go to do that. I think there's several of these concepts that I'm having to do for the renderer that just aren't going to exist at all, which is going to be fun. Okay, so I guess let's take a look at why are you not going to definition? I wonder if the K API is screwing that up. All right. Apply global. Okay, so we have this material apply or fail, which is only in here, which I guess that makes sense. This goes ahead and gets the shader by ID, which is interesting because we already have the shader here. So that's an interesting note. Maybe we stick with doing it this way instead of by the ID. I suppose actually that's a really good point. We should probably check to make sure we actually get a shader, right? So we'll say K error unable to obtain terrain shader. Return false. All right. So it looks like we do the projection, view, ambient color, view position, render mode, projection, and view here, just for the UI shader ID. Okay, so actually, I know I don't have this macro, but I am going to copy all of these lines anyway. And we are going to just manually apply the globals here. So I'll put these, and we'll just get rid of these extra things. So the material system was also managing our shader locations for us, which means that the it seems kind of backwards, doesn't it? Like, I feel like the shader system should probably maintain that. But then if the shader system maintains it, I don't really have a quick way to look that up without using something like a hash table, which is kind of gross. That's probably the reason I did it this way, so that the owner of it could know what its locations are. So I guess I should probably cache that. Okay. I guess I could just cache it statically. I don't really want to do that, though. That seems dirty. Where do I put that? Because I don't have a terrain system per se. You know what? I'm going to put it here statically for now. And then if for some reason I need to move it, I'll move it. So I'll type def a struct, and I will call this terrain. I want to call it material locations. Shader locations. Yeah, I guess that'll work. All right. And I think these were U16s, I want to say. Yes. In fact, these are the uniform location. Yeah. I'm going to copy all of these for right now. All right. And then I guess I'll do static terrain shader locations. Terrain locations. Note, might want to hold this state elsewhere in the future. So I get the feeling we're probably going to have a lot of temporary code until we get this stuff straightened out, because there's a lot of things that we're going to have to tackle that we just kind of need to get it up and running to see how it works. So what I'm going to do is acquire locations. And then I'll keep some sort of flag as to whether those have been acquired or not. You know what? That's poopy too. That is poopy too. I'm not going to do that here. I'm going to do that the first time I load a terrain. Which will be here. So let me put these here. And go back up here. And I'll just put a B8 here for loaded. That seems kind of stupid, but that's what I'm going with. All right, so terrain locations dot view. And I'll have to get these. I think it's just get by ID, if I recall correctly. Oops. This is apply. Here we go. So I guess that's a fair point too, is I should probably, but again, I don't have a state, so. I've got to find somewhere to actually do that. Okay. So what I'm going to do, I'm just going to copy this whole section and put it here. Delete this line. So terrain locations, material shader ID. Oh wait, I don't need that. I suppose I could save that off, but terrain locations, material. Nope, don't need that. Should just be dot projection. So we pulled projection, view, ambient color view. Yeah, so all these. Let's see. guess I really wish it didn't count those underscores as words. Slowing me down a little bit. Let's see. So that's going to be I need to figure out column select, I think. Haven't figured that out yet. Then again, it's not something I have to do all that often either, so. Do I need to save all of these? I think I do. All right. I think we said we were keeping shininess. Yeah, okay. So we've got those cached. I need to change this to terrain. Let's go back down to draw. And we're going to now call this terrain locations projection. Now we should be able to set these. Now we don't have this stuff cached yet either. Which is making me think we might want to save that off to like the frame data. So where do we get those things from? Because I think that just takes a void pointer to a value. Yeah, so these are literally passed in as pointers here, which we're not doing. We're not doing over here. So we'll either need to pass in pointers, which I suppose for projection view and model, that actually kind of makes sense. So let's go ahead and do that. We'll say yeah, const mat4 pointer projection, const mat4 pointer view, const mat4 pointer model. That takes care of some of them. Render mode. Render mode. Does this actually take in render mode? It does take in render mode. Okay, I guess I could do the same thing here. So U32 render mode, because I could just pass that in, right? Ambient color. So ambient color is passed in here as well. Okay. I can live with that for right now. I guess I can do that right after model. Mat4. Well, that's a vec4, sorry. Vec4, pointer, ambient color. That should be const. Oops. And view position. Do I really pass that here too? I do. At the end here, I guess. Oops. All right. So I guess should probably update the function signature and the header. So let's copy that and go to terrain.h. Render, here we go. Okay. Go to terrain.c. So now we should be good as far as that's concerned. So that is for globals. Let's just fix our tabbing here. All right, so that's our global variables. Our instance variables. We're here. Here's where we're applying all the directional lights and the point lights and all that stuff. I guess we really do need this whole block of code, which kind of sucks that we're having to copy this much code. This makes me think we need to refactor this to be less copy pasta in the future. But for now, I'm going to roll with it as is. So what is that? 8 spaces, I guess. And then get rid of these. Let's see. So we don't have the textures. So the 3 textures, I'm actually going to comment out for right now. And terrain locations. Now, we don't have a material. So our diffuse color is basically going to be, I guess I'll just use white for right now. So vec4, whoops, yeah, I thought so. Equals vec4 1. Okay, and then we'll just pass white. All right, so that's diffuse color. I guess I could set that as static right now, so we don't have to call that every time. Oh, I can't do that because it's calling a function. Whatever. Shininess. So I guess I'll go ahead and set a value here. Did I happen to put anything here as to what the default is for that? I did not. Looks like that's got a shininess of 64. Shininess of 10. Paving has a 32. Yeah, all right, let's just default to 32 for now. So we'll say F32 shininess equals 32. Right, and we're also going to put a to-do. Hard-coded temp. And should just be able to pass the address of shininess there and have that. So that is the material properties. Directional light. Let me just fix the tabbing on all of this real quick. All right. So use of undeclared identifier directional light. I'm guessing that means that we don't have that. We don't have that declared or included. So that is in light system.h. Okay. So I'll go to the top. Include systems light system. All right. Let's get rid of these extra things that we don't have here. Oh, this has got to be terrain locations. Terrain locations. All right, so that's directional light. We have a to-do frame allocator here. We also have it here. Don't we have... Oh, we aren't passing that here. Okay. I need to straighten that out at some point. I feel like I've come across that a couple times before, and I've said that before. All right. So that looks fine. All of this looks fine. So I'm just going to swap this over to be terrain locations. All right, and then remove this and terrain locations. And I think that's all we need to do for our instance variables. All right. And now the only thing we have to do at this level is the model, which is going to be this apply local. And it literally should just be a single call to shader, shader system uniform set by index. The index is going to be terrain locations dot model, and the value is going to be model. I think that's it. Oh, it's probably going to be the address of model. All right. What is this bleating about? Too few arguments. Render. Oh, that's asking for the renderer plugin. Well, that's definitely wrong. That shouldn't be doing that. Okay. That's a copy pasta issue. Okay. So let's go back to the renderer front end. Do the H file first. This should not be asking for the plugin. So, okay. And we'll go front end C and remove that. Okay. That should be here. Incompatible pointer types. Oh, this wants render data. I forgot about that. I can't just pass the geometry. Okay. Geometry render data, render data. Render data dot geometry equals the address of T geometry. Right, and then this should just be render data. Assigning to geometry. What is this bleating about? Const geometry. Discards qualifiers. Did I take that as a const? I don't think I took the geometry here at all, did I? Oh, wait a minute. the terrain as a const. So why would the renderer need to have a non-const there is my question. So if we look at the Vulkan backend, the render geometry data takes a pointer to that, but I don't see any reason why that can't be const. Although should probably aim for const correctness here anyways. Oh, I just did the H file. This should take a const. Go to the definition of this. This should take a const. And then the H file. Const. There. We should probably get in the habit of doing that more often. I have a really bad habit of not making things const, especially pointers that shouldn't be modified. Okay, so I probably should have stopped a while ago and asked, do you guys have any questions or comments, things you want to discuss? I could use a 5-minute break. This is designed to be an interactive stream. Sometimes I get really into what I'm doing and I forget to sort of do that part of it. But yeah, if you guys have any questions or comments along the way, feel free to chime in. I do keep an eye on the chat. Smudge, how's it going? Good evening to you too. Good to see you. All right. What is this bleating about? All right, this is kind of what kicked off my What are the next steps on the roadmap, and do you plan to start some test projects like a game anytime soon? Be nice to drive the development features. So yeah, that actually is part of the plan. So one of the things to obviously test this as we go along is going to be to make games. So we do have on the agenda for later this year, we are going to make probably a admittedly very simple game on this, just to test drive everything. So I do have something in mind for that. It's going to be a pretty simple project, but we should be able to do it nonetheless. Realistically, we probably don't need terrain for that. I just kind of wanted to get it in because it's kind of a visual thing. The only other thing I can think that we probably should have for it is audio, and I think at this point we could probably just like start thinking about putting together a game. So we're actually not that far off. There's a lot of stuff that needs to be refactored and changed and moved around and whatnot. But I don't think any of that stuff is going to stop us from making a game. So we're actually not that far off. We have the ability to load and unload different levels now, which is a key part of making a lot of games. Of course, some games don't actually require that, so we probably could have even done it without that. But yeah, we are going to have to start looking at audio sometime soon, which should be an interesting topic all on its own. But yes, the answer to that question is yes. That was a convoluted answer, but the answer is yes. What about physics? So physics is something we're definitely going to tackle, probably in a few different phases. As you may or may not be aware, a physics engine alone is something that could take years to develop. So we probably will discuss some very, very basic physics, and implement those things here. But that's probably going to be one of the places, at least initially, where I'm going to have a plugin that uses an existing physics library. Only because, like I said, a physics library can take a very long time to actually develop and get right and get stable. So, like we are starting to do with some of the other systems and things, that is going to be a plugin. Maybe implement the game physics on a weekend. I could maybe do that. I could look into it. I haven't actually gone through that, so that might be worth doing. I've been reading about it, and it's like I could do something very, very simple. And maybe we could get some use out of it. I'm just trying to decide what the value of that would be. But again, if I do it as a plugin, then I could say, well, we kind of roll our own, and then we also have the other one that's available as a plugin. And then whichever one the application wants to use, it just says, okay, use this plugin or use this one. And they'll both, sort of work through the same interface. Don't want to change this. Why does the geometry render data have a model matrix? That shouldn't technically be needed. It's just another copy of the model matrix that we have for no reason as far as I'm concerned. I know the material system, I think, might be using it, but I don't think it has to. Ooh, I forgot these calls in our code. Shoot. Before I forget. Needs update. this is something that I had forgotten that actually needs to be done. All of this should only happen if we need an update. Because we don't want to be updating all of these uniforms if we don't need to actually do the update. So remember how we have the frames in a flight, and we only have sort of one set of descriptors that gets used for all three. Because of that, we can only update certain things once per frame. And that is especially true on like the material instance stuff, hence the needs update. And so we shouldn't be doing any of that unless needs update is true, which we haven't actually set here, and I get that. We do still need to bind it though. So shader system bind instance, and the instance ID comes from the material. I don't think the terrain has it. Does not. Technically, we can render more than one material at once, which is why we need an instance ID. Now I'm kind of wondering if we should do that though. Or whether we just count everything as globals for a material and keep it for the terrain and keep it simple. That would actually simplify a lot. Need to think about that. Because when we do the material system acquire, it does all this hash table stuff. And then it obtains somewhere in here. There's a generation, which is important. And then the ID. And then an instance ID should be in here somewhere. Zazo, hello. I'm curious about your choose on terrain geometry function. Why choose a direct backend Vulkan function and not the same thing, more agnostic on this function? Sorry, I don't know if you understand my question because English is not my first language. No, I think I get what you're saying. So the only reason that I decided to do it as a different function, it's more of a temporary thing, is because I'm not 100% sure that it's going to be the same. In fact, I know it's not going to be the same because the way that we're going to handle materials and the information that gets passed along with the geometry is going to be different. So we're not at the point where we have that difference yet, but it's not going to be 100% the same as standard geometry. And I haven't decided yet if I want to just sort of have a structure that goes along with that, which I don't think is going to work because of the difference in the data, the way the data is actually laid out in memory, or just a completely different structure altogether, which I think is what I'm gonna have to do. So right now, like all of this is the same. So if I do, I assume you're talking about this. Like, why do I have this when I have all of this? Right? I assume that's what you mean. So yeah, for right now, it is very much the same, but I don't think it's always going to be. And I'm not 100% sure it's going to be. And in fact, I think this terrain or this geometry render data that's getting passed here is going to be different. I'm pretty sure of it. So I'm using that right now just to kind of get it up and working. But I think once I actually start to get in there and implement the material stuff, I think it's going to have to change. I hope that answers your question. Worst case scenario, and I get down the road and I decide I don't have to change it. All I have to do is literally just remove all these functions and just point them back at render draw geometry. I just didn't want to potentially start making changes in here and then go, oh yeah, it's going to break other stuff here. So I just find it easy to separate like that. Okay. Cool. Yep, no problem. System. So I need the material internal ID. So when we load the material, that's when we acquire it, rather. I'm really tempted to just not deal with all of this for terrains and just say everything's global. Because even if we have multiple instances of it, it's not really going to speed things up that much to have the different scopes. Yeah, I think that's what I'm going to do. That's going to reduce a lot of complexity, all this stuff. I won't need any of this stuff then, if that's the case. So let's go ahead and I'm going to remove the concept of this. And I think in here there was apply global, which I think all we had to do here was one call to apply global after everything had been applied. So I can do that literally down here. Shader, system, apply global. And I'm going to come back up here and delete this. And I'll say apply uniforms. All are global for terrains. That's going to simplify this a lot. All right. Oops. Deleted too much there. Let me just fix the tabbing here. I really need to get my auto formatter set up too. That would help a lot. Okay. So everything's global. That will take care of that. That does mean I'm going to have to change the shader, though. One box, please, thanks. Actually, I mean, speaking of box, she's laying over there. This is still complaining because that's const. I shouldn't... I'm just going to remove const from that for now. I don't like it, but it is what it is. Okay. Let me do a quick build. Let's go to the terminal and see what I broke. Must use struct tag type to refer to... Oh, I probably left it in the renderer plugin. Let's see. That is... Yep. Okay, that should solve that. Okay, so it builds. It's not going to run yet, which is not surprising. But let's jump back to the shader stuff, because I think at this point we're looking pretty good on the terrain rendering portion of it. Right, this is most of the steps I think that we have to take. If I'm missing something, we'll definitely see it, but okay. So let's go here to shaders, and we will create a shader config for this. Actually, shaders. Let's do a copy of shader dot built-in dot material shader config, and we'll call that shader dot built-in dot material dot terrain dot shader config. Right. And then we'll come over here and we will open up this one. So we're going to call this built-in dot terrain. The render pass is going to be compatible with the world render pass, I think. Vertex fragment, that works. Instead of material shader, we are going to terrain shader. Terrain shader. We want depth testing. We want depth writing. Here's the attributes we have for now. I think that's fine. The only thing we're going to do is we're going to change all these scopes of everything to global. So, whoops. let's see, replace 0, replace 0, replace 0, replace 0. Same for this, and this, and this, and this, and this. Now, we did, however, comment out the textures. So we'll go ahead and turn those samplers off. And that should do it. I think everything else in there is correct. So everything here now is global. Okay, so that's the shader config. Let's have a look at the, I guess let's take a look at the Vertex shader and make sure that it doesn't have anything. So this is the global uniform object. The push constant is here. So this is actually wrong. You know what? Let's pull up the shader config over here because these need to actually be kind of in the same order. So, so we have projection view, ambient color, view position, mode. And then we're just going to start adding vec4, diffuse, color. Let's see, directional light. I don't have those structures over here. Poop. Okay. Directional light. Light. This is an array of those point lights. So we have to const int point light max equals 10. And we'll say point light max p lights. Oops, that's in the wrong spot. What am I doing? Okay. Then we have a int p lights, and then a float shininess, and a mat4 model. Right. So this goes away. That's a separate mode. Let's see. And I think the only other thing I have to change now is where this comes from. So this is going to be, instead of view push constants, it's going to be, should just be global UBO. And then global UBO and global UBO. I can't help but notice this doesn't look like VS Code. It is not. It's Vim. So I guess if you weren't here at the very beginning, I'm trying out a new setup. So I've got a fresh Arch Linux install. I'm trying the new window manager that's out there. It's fairly new anyways. It's called Hyperland. So it's a tiling window manager. And then I'm using Vim because I've been daily driving Vim at work for some time now. And I've been wanting to translate over to that at home. And so yeah, this is Vim, or at least my own sort of customized version of Vim. Let's see. So if we write that, I think I was able to build successfully here. Let me just get back to the main directory here and build. Yeah. So I can actually run. Oh, no. Let's see. Go to terrain.c. So I can launch the test bed. And the nice part is it actually launches up here automatically right next to it. So it's, I can very easily, test and do what I need to do, and then be able to, debug right next to it right here. So if I wanted to, insert a breakpoint somewhere along the line, and let's say I wanted to go to testbed main and do not boot but update. Like let's say I needed to debug something in update, I can just slam a breakpoint right there, and I've got everything I need in here. So I prefer this setup quite a lot to VS Code, just because I find navigating in Vim is quite a lot quicker for me. I'm still getting used to some of the keystrokes and stuff, but I've been using it at work for a while now, and I really, really like it. So, yeah, that's basically that. So I can continue, and I can quit the application. Cool. Plus, there's also that awesomeness, right? So this is the desktop environment that I'm using, right? So, anyway. Okay. So I think we've kind of done some moving around and whatnot. Tonight was also me kind of getting used to this new setup and making sure that everything works okay. So there were a couple small bumps, but yeah, it is a pretty efficient workflow. I'm liking it a lot, and I find that like every day that I use it, I get faster at it, which is pretty sweet. So yeah, it's definitely working out pretty nice. But yeah, I think this is probably where I'm going to go ahead and end the stream for tonight, just because we've done a little bit, but I mainly needed to kind of get this new setup up and running. So let's see. So what's your monitor size? So I have a 28-inch monitor. It's a 4K monitor. The coding one, yeah. Yeah, it's just a 28-inch Philips. It's a 4K monitor. Can I exit Vim before I go? Yeah, that's the meme, right? Here. Oh, I didn't save one. Let me save everything. There we go. Exited. Yeah. :Q. It's your friend. Or if you really wanted to be brutal in this windowing system, you could just hit the mod F4, I think it is, to actually close out everything, right? So, but yeah, I think that's probably where I'm going to going to end for tonight. I think we accomplished a decent amount. And I think next time we're probably going to press on with this and make a little bit more headway. I didn't make as much as I quite wanted to tonight, but that's because I've really been wanting to switch over to this new setup, and I finally went ahead and did it. And of course, there's issues with that. I've got a list over here of stuff I have to address. So anyway, let me see who is online, if there's anybody online. Let me see. I will go ahead and, you know what? I'm going to raid Ferris offer again. Because I don't see anything online right now that I necessarily want to raid. So I'm going to do that. And for those of you who don't know what that is, there's another game dev here on Twitch who he's making a pretty awesome game called Heartbound. And he's got a number of pet ferrets. And he figured out that he can set up a stream. It's a 24-hour stream of his ferrets. And they basically have all of their food and medical bills paid for just by ad revenue from the stream, which is pretty awesome. So I like to support that. He's a really cool guy, and his ferrets are super cute. So that is what I'm going to raid. And with that, I will see you guys next time. Thanks so much for joining. See ya.